So let's go on and restart our discussion of web vulnerabilities. Another class of classic web vulnerabilities is file inclusion. File inclusion is used fundamentally to modularize your web application. So you define your code in a certain module and then you include it. People that don't fully understand sometimes the mechanism of inclusion in certain framework misinterpret how it's done or the scope of the variables of or other aspects. So, for example, one thing that is interesting is that code could also be included remotely, and this is one. It was one vulnerability that was heavily exploited in the early days of PHP. You could actually, if the file name was based on user input, you could, for example, put HTTP something, and the script would actually go to the site chosen by you, download PHP code, and execute it, which was a way to perform large-scale compromise. Another problem is the fact that sometimes, and this is an example of an attack like that, sometimes people don't even understand where certain variables are included. So look at this example. There is the main application, there is global variables that is set, and then there is a library that is included, okay? And up to here, everything is great. Fundamentally, the inclusion, okay, means that it is like you take this file, you evaluate it, and you put it there. So this file will see this variable in its own scope, and everything works fine. And this is a classic example that is very typical of web application. The developer of this didn't think that somebody could invoke library.php separately, okay? So because things were not configured correctly, the attacker could actually call library directly as, you know, a script like any other, and pass as include path the same variable that is written here. But since this code will not be included with this variable will not be defined, and since in this case, for example, there is that automated variable generation in PHP, this will just go automatically, will be included, and so library will get to here, and the include path will be set by the attacker, and this can be set to a remote URL, and so you set up a math.php in one of your hosts, and suddenly you can execute code on that machine, okay? Is that clear? How there are all these different parts that come in. There is the fact that, you know, this code is divided in subcomponents, but this should not be callable directly. In addition, there is the automatic creation of variable, and in addition, it allows the inclusion of code from remote hosts, okay? So, pretty broken. Of course, another attack is HTML injection. So fundamentally is the ability to modify HTML code using content provided by the user. And you can see the many things you can do with this. You can, you know, inject forms to dupe users into providing sensitive information, or you can insert an iframe tag, and so you can force people to or trigger the download of a site under your control. So, and in general, all these forms of common injection or inclusion are a sanitization problem. You don't want user-provided data to reach a sensitive location. And this is something that we will see over and over again. How do you do it? For example, in PHP, you have functions that are absolutely devoted to this. So sanitization is such a problem that most frameworks have exactly a function that tells you this is how you sanitize a string for a certain use. You know, because you have to sanitize a string differently if you're just including in HTML and you don't want that string to mess up with your tags, or you're taking a string and you're passing to the command line and you don't want that string to be able to fork additional commands. So you can have this, you know, strip tags or remote HTML entities. or you can have escape shell arg, escape shell command. All these are fundamentally utility routines that are done the right way. Why? Because doing it yourself is problematic. Sanitization is such a problem that should not, it's like encryption. Do not come up with your own encryption. If a framework provides functions that allow you to actually remove those bad things, use them. You know, they're used for a reason. And we will see an example that is interesting. But let's talk about one of the most powerful attacks that there is. It's also a form of injection. It's SQL injection. So this is an attack that has been responsible for data breaches of biblical proportions. The thing of the SQL injection is that with a command, by injecting commands into a SQL query, you fundamentally can either read everything from a database, modify the database, have all sorts of side effects, and therefore it's a super powerful attack in terms of disclosure. Not as much as, for example, command execution, but of course data disclosure might eventually lead to command execution. So the basic idea that you can imagine here is the obvious, remember, create string and then parse. So the right way to do always things is first parse and then, execute. However, we can have the same problem here that you can see that if somebody first creates a string and then asks the parser, in this case the SQL parser, to execute it and to parse it and execute it, then of course there are all sorts of problems. The special characters here that you can use are the tick, because the tick is often used to, around strings. The dash dash that for certain version of SQL will make the rest of the query a comment, and so you will not be disturbed. The space plus variables that are internal to the PC, to the system, percent that is using like query. So you can do all sorts of things. You can modify queries, probe the database, and even run commands. For example, Microsoft SQL Server has this XP command shell, so it's a utility function. If you can invoke it, it will just execute commands for you. It's like system, fundamentally. Just to give an example, this is a super ugly, I thought about sort of upgrading this version, but I say it's so antique, with it's awesome. I love it. So this is a classic login page of a super secure application. And you can see the form is a classic form, username and password, that will post to login.asp the content of your username and password. So this is stuff that it's super easy. And if you look at the login script, you remember we talked about ASP is active server pages. They're a combination of HTML and code. Here you have an example. See, it's getting username and password from the form, and then create an object that is for accessing the database. Here creates the query itself, and you can see here the username and password are copied verbatim, and then open the connection and fundamentally requests the executes the query using the connection, and here fundamentally checks if there is if there are enough records. So if there are no records with that username and password, it will deny access. If there are more than one, of course there should be only one, then it will allow people to get in. This is how I love also this. This is a database. You can see their username and password. This is your table with of course there are various columns. And here, in order to bypass execution, we use the tick or 1 = 1 -- technique. That is, sort of like the 1 of 1 or 1 = 1 of SQL injection. The basic idea is that by providing this value, for example, in the case of the username, you fundamentally close this tick. So this tick gets closed by this tick. And then you do or 1 equal 1. And doing or with something that is true make the whole select clause completely true. And so the database is returned in its entirety. Okay? Because it's fundamentally select this from this where true, which means give me everything. So you get all the lines of the database. And since the way in which the correct username and password was verified in the script before was just if you have a non-null record set returned from the query, you're allowed to get in. You can bypass security. Okay? And note that this tick makes sure that everything that comes afterwards is considered a comment, and so it will not disturb the parsing of the query. So this is the most basic SQL injection. Yes?
So the dash just go to the end of the semicolon?
Say it again?
The comment, the dash.
Yeah, the comment will be from here
It just goes until the semicolon?
until the rest of the line. Yes,
Okay.
everything. Okay? And of course, you can inject not only select statements, you of course can insert statement, okay, and you can inject value. So, you know, of course, you have to be very careful because when you have an insert statement, you have to match exactly the number of value that you're providing with the values that are inserted. Of course, you can inject update statement, delete statements, all sorts of things. For example, you can imagine a delete something from a count, and you modify this, and suddenly it becomes or 1 equal 1, which means that your whole database gets deleted, which is, you know, not exactly the intended thing. So how do you know if something has a SQL injection? Well, there are two main ways. One is the negative approach, which means that you put some crap in your parameters, and you see if the system bombs. Okay? Nowadays, most systems are very resilient to this kind of things. Once upon a time, you could find, you know, I remember I was pen testing a web application. It was the first test. I put a tick in one of the form, and immediately I got this nice stack trace from Java saying that there was all sorts of mistakes, telling me what the query was. It was like, okay, I'm done for the day. You know, it took me 5 minutes to know everything about this application. Sometimes if they don't show you errors, it's cool to try to provide, it's called, we will see later, some form of blind SQL injection. If you, for example, do 7 plus 5 instead of 22 in one of the fields, and you get the same query with 17 plus 5 and 22, you know that the value is first put there and then parsed once the query is put all together, which is an obvious sign that there is potential for SQL injection. Okay, so this is actually, it's also somewhat stealthy because it will not create any error logs in your thing. Then we have our friend, the union operator. And the union operator is cool because it allows you to get information from a bunch of other table. So the basic idea, if you have, for example, a query from a table called product, and these are the fields that are passed, you want something other than the data in product. So how do you do it? Well, you put something that you don't care about, tick, which will close this tick, and then union, and then you select something else. You have to have the same amount of arguments, but then you select something else, and for example, you get information that you're interested in from accounts. Okay, this will return to you all the product information plus all the account personal information, and that's how, you know, many of the breaches are carried out. You find one SQL injection, and then you use the sort of union trick to add and extract information from any other table you're interested. And of course, you're limited by the, you know, by the number of and type of columns, but you can always, you know, find tricks around it. Okay, and of course, you have to have the number and types of the parameter down, okay? And if you don't know, you could always use null, and as you will see, you can also sort of like find out using null the number of parameter. So you want to know the number of parameter, you don't have access to the query, you select null. You know, union select null and say error. Union select null, null, error. Union select null, 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 and you get the query. It's like, okay, 3 parameters, okay? Now, what, because otherwise the query will fail.
Yeah, but why not an asterisk?
Say it again?
Why not an asterisk?
Well, because then you cannot, if you do an asterisk, I mean, null is fundamentally anything, but you want to know the exact number of parameters. You don't want just the query to work with the asterisk, okay? All right. And then if you want to find the type of each parameter, you can do additional selects by putting the parameter and leaving the other null to find out, okay, this fails, okay, this succeeds. So now you know that the second parameter is a string. You can do that for integers and so forth so that you map exactly type and location of the parameters. You also, if you don't have access to the schema, you want access to the actual columns, so you want to know the tables and their columns. Depending on the system, you have different possibilities. In Oracle, you can use the user object table, for example. In Microsoft SQL, you can do the sys object table and the sys columns table. And in MySQL, you can use the information schema in order to get out the information that you need. Direct SQL injection is cool. There is also second order SQL injection. There would be something, imagine, that you store in the database that then, when it will be used in a query, will create the SQL injection. Yes?
This is about, I guess, SQL injection in general. Can you limit the scope of SQL queries to certain tables when you're on, I guess, running your client?
Good question. So you want to say, well, I would say no, because, I mean, you can say, I mean, if you think about it, a SQL query is limited in scope. You say, use this table for the results. So it's the... You can, well, I mean, it's difficult to say because, of course, database have users, and you can say this user can only touch these databases. But of course, usually when you have an application, unless you're crazy and you compartmentalize all this, fundamentally all the code has access to all the tables. Maybe there is, an admin portion and a non-admin portion. Yes, Fish. You cannot?
For example, in MySQL, you have the privilege system that you can grant privileges for certain tables to certain users.
Absolutely. You can. No. I'm saying you can provide to certain user access to a selected number of tables. The problem is that you cannot base it on a query. You cannot say this query will touch and only touch this thing. As we will see in solution to SQL injection, the right way to do it is with prepared statement or stored procedures, and in that case, you cannot change the scope of that thing. But it's a good question. So this is an example in which the attacker sets the username to John tick -- okay? So that is stored in the database, and for example, at a certain point where the attack changes the password, okay, suddenly is tick John -- is put in, and now the password is that for the account that is being changed is John. So an existing account, and by changing the password, now you can hijack that account. So this is just an example of stuff that you can store in the database that is later used in a query, and because it's not been sanitized, can actually change what the query does. We talked a little bit about SQL, blind injection. So when you don't see the error messages that come back, or you don't see even the results of your query, you can still find ways to extract information using SQL injection. Okay? The first thing is, of course, to do something like in this. Okay, this is an example of a news site. You have an ID that produces a press release. So how would you exploit this? Well, first of all, you can try, first of all, to determine if there is actually an injection. So if you see something like ed equal 5 and 1 equal 1, okay, and nothing changes, you know that they took that value, they put in a query, and they parsed it, okay, because nothing has actually happened. So this is what happened in the database, and this is the query that worked, produced the same identical press release. You say, bingo, I have actually a form of injection, okay? And this is the first step. But then if you actually want to extract information, you can add questions that are true or false. So you can say username, of whatever is the server that is running there is Haxer in this case. If it's not the case, it will be false because you put in and the query will fail. If whatever put here is true, then you will get press release number 5. So fundamentally, blind SQL injection is when you find a way to have the server being an oracle for true/false. And the cool thing is that you can, and there are tools for doing that, and you have to use scripting, but you can say, is the table name first letter A? True or false? No, you don't get the press release, then it's not A. Is it B? Is it C? Is it D? And then you iterate, and one by one, using this technique, you can actually map all the information, okay? Of course, it takes, it creates a lot of noise and requires a lot of attempts. The SQL injection solution, of course, are, to use stored procedures or prepared statements. And we'll see both. These are ways to really take away that problem of having a string put together and then parsed. So you have to do some work before, so the string is pre-parsed, and you don't have that problem. For stored procedure, fundamentally, you have something that store creates the procedure, you can see here, where you actually call a function, okay, specifying the parameter, and you say, whenever you call this with this parameter, what really you want in select this, etc., and this is the parameter. And you can see that by storing the procedure, identifying the parameter, and identifying the parameter here, you have done in a way, manually, the parsing for the application. Now, when you provide a value of 5 and 1 equal 1, that will be this parameter. It will be considered one parameter because this will be in some way compiled, and therefore there is nothing that can be can be used to modify the way in which that particular procedure is parsed. Okay, and so you can see here, for example, you can prepare the call, and you just execute the query, passing the parameter ID. The more common solution is to use prepared statements. This is the same thing. It's sort of like providing a printf solution, a printf-like solution in which you say, these are the parameters that need to go in my query. So parse now, and then fill the parameters with the value that you obtain from the user. And this is, it's a little bit painful because it requires a two-step process in which you first have to create the string, and then you bind the parameters to the actual values. But of course, this immediately removes all the problems of SQL injection because nothing will work. This is an example in which there is a statement. You can see that here you prepare the statement saying, okay, there is only one parameter, and that's that question mark. Okay? By doing this, by doing that call to prepare, you actually have pre-parsed the query before it is actually executed. And then you bind the parameter and you say, hey, this is, bind the parameter type and the actual value, and it goes and it gets bound to name, and then the the query is executed and the results are extracted. So it doesn't matter if city, the value city has a bunch of injections. It doesn't matter. It will be just the name of the city. So these are the two main ways in which you prevent SQL injection. Fortunately, nowadays most frameworks like Ruby on Rails and other frameworks like that provide all these for free. So unless you majorly shoot yourself in the foot, having a SQL injection is almost difficult to come up with. Of course, there are a ton of legacy code out there on the internet that is full of stuff like that. And so there are, in the, I would say, mid-2000s, there were a whole series of papers in scientific conferences about detecting SQL injection using dynamic analysis, static analysis, because it's a classic sort of like taint analysis, and we will talk about that. It's a classic taint analysis algorithm where you just have to say, is there any path in the execution of this application in which unsanitized input from the user will reach the creation of a string, which will then be interpreted as a query. So this is one of those type of vulnerability models that are easily automated and can be easily used for detection. A less known form of injection is XPath injection. So XPath is a formalism fundamentally to identify parts in an XML document. And the thing is, if, again, user input, if this is, for example, used to analyze a document that contains username and password, you can have queries that say, hey, find any element within the XML document that has a certain username and password and matches whatever is passed to this application. So you can see, since you are fundamentally creating a query, you can inject a string and obviously modify the way in which XPath operates. From this point of view, XPath as let's say a query attack. I haven't seen a lot of that in the wild, but definitely it's something that is very similar to DOM-based cross-site scripting, which has the same concept of using sort of like the injection as the basis for generating the cross-site scripting. So here you can see this is how that document would be used. You can see that there is the XPath expression that is used by using the data provided by the user. And so if the user introduce again tick or 1 equal 1 or quote quote something like that, you can see that the final solution would be that you see all the different quotes are now balanced, and so the final string will be this, which is fundamentally give me a every single piece of text in the XML file, and therefore the authentication will succeed. Very similarly to the SQL injection example that we saw at the end. Now let's talk about other classes of attack that are based on fundamentally tricking the user into doing something that would either disclose personal information or perform action on behalf of the user, or the user will perform action on behalf of the attacker and therefore achieve some goals. We will see cross-site scripting, cross-site request forgery, and clickjacking as example of this type of information. Why we do this? Well, mostly because you want to, obtain some credentials, so a session ID, a cookie, or because you want to execute code on their machine and have some kind of capability on the machine of the user. The cross-site scripting attacks are fundamentally a way to bypass the same origin policy. If you remember correctly, when you download JavaScript, that JavaScript can only access information associated with the site from which you downloaded the JavaScript. Very important concept. So how do you get around it? Yes?
There is something that is not clear to me about
Okay.
the same origin policy.
Go for it.
What you're saying doesn't mean that the JavaScript you're executing processes a request to another website.
Processes request. Can do a request to another website, no problem.
No, to another one.
Yes, no problem. Can, of course can.
Okay, so it's not limited to the scope of the website we're downloading.
No. It can access information that is stored by that website. So for example, the surrounding HTML or the cookie.
On the client side.
On the client side, of course. Yeah. So that's a good question. Let me. So when you download JavaScript, so this is the web server, and this is the user. So when, for example, if this has set a cookie here, okay, so JavaScript that is downloaded from this website will be able to access this cookie. Also, the JavaScript that is downloaded from here will be able to access the surrounding frame information. But the JavaScript here can also call to another, for example, and have an image, source, something external, and can, of course, make external call. And actually, this is usually the mechanism in which once you do a cross-site scripting attack, you exfiltrate the information by calling an external server.
Yeah, that's how you de-anonymize for users as well.
Exactly. Same identical thing. So as you will see, cross-site scripting can be reflected, stored, or DOM-based. In the case of the reflected attack, fundamentally you exploit a flaw in the server application in order to send JavaScript back to the user, but JavaScript that you are in control. And you do this fundamentally by tricking the user into clicking something that has your content in it. That clicking will generate a request to the legitimate side, and the legitimate side will have some flawed process that will take some of that part and send it back to the user, and we'll see an example. Stored attacks are a little easier to understand because they're obvious. If you can store information in a website, for example, a guest book, and you put JavaScript there, when somebody goes to visit the guest book, it will execute your JavaScript and can access all the web-related information. And then you have DOM-based attack, where in this case, these are more common in advanced applications that, for example, receive some data and on the client use the DOM interface, the document object model, to modify and use user control or attacker control data to do the modifications. At that point, you can inject JavaScript on site. You can add requests to whatever you want, and so it can be pretty effective. So this is an example of how you would exploit a reflected cross-site scripting attack. You would have, for example, a page that wants to be very nice. No, not page. A server that wants to be very nice. And whenever you provide a URL that doesn't exist, it gives you actually the URL that does not exist. This seems completely harmless. But this is the basic concept of cross-site scripting. If I send to the site something, and that comes back to me in some form unsanitized, you have cross-site scripting. Okay? Of course, if you send something to the site, the user, and it gets sent back to you, that's not a problem. You decided what came back to you. The problem, if you can have the user, the victim, click on something like this, you can see it will be the browser of the user that click on this. It will go to usbank.com, ask for this file, okay? This file will say, oh, it doesn't exist. And the user will receive as an error message this, which will be interpreted by the browser of the user as JavaScript. So will be executed in the context of the bank account, will be accessing the cookie of the bank account, and will ship it to, there is no send cookie to in JavaScript, but you just put it in an image source or whatever you want, and you can exfiltrate that information. So this is something that you often get confused because it's not always super clear. So the bad guy has to set up some malicious web page, a click on an email, something to trigger the victim to make that request. This is very important because nobody will, shoot themselves in the foot, without any checks. But sometimes, suppose there is a malicious page, and in this case, the malicious page can also just have an iframe. They don't have to do a real click. In this case, there is a link that does the trick, and so the page is set. The user click and request from the bank, this image source, this tag with image source evil.com plus the content of the cookie. Okay, when this is received by the browser, so this goes to the bank. When it's received by the browser, received by the server, it will say file not found, and then script because it has not been sanitized. And when it's received by the browser, this will be interpreted exactly as JavaScript and will generate a request for, get/sessionid to evil.com with the content of the cookie. So malicious page with link, user clicks, file goes to the bank in an error message returns that content, gets interpreted as JavaScript, and has access to the session ID of the user in the cookie, and this gets exfiltrated to the email, so to evil.com. Reflected cross-site scripting, of course, is a little more obvious. You have some database, something that is persistent on the server side. So the bad guy is able to put content here, and that's why, take Piazza. Suppose that somebody will say, did anybody use Metasploit to generate the format string, blah, blah, blah. You put there, if you try to put JavaScript in that page, it will be heavily sanitized because, of course, this is something that you all go to Piazza and visit that page. If that text was not sanitized and would allow the inclusion of JavaScript, they will be executing JavaScript in the content of Piazza. And so they could steal your Piazza precious session and go in, log in as you, and make awful comments on your behalf so that you're in trouble. Okay, so this is how the stored. This is still reflected. I was talking about the stored one, so sorry about the confusion. These were still talking about the reflected here. Okay. This is another example. So how do you find this? If you look at code and you want to find a cross-site scripting attack, you look for input that comes from the parameters of the query that is returned without validation. It's as simple as that. And that's also why it's very difficult to catch in all situations. So you can see here, if you put hello world, you see hello world coming back. And then you can see here, if you put as message something that says script, alert, something, you can see that this is returned by the user. And we talked about stored cross-site scripting attack, and again, this works very well with bulletin board system, blogs, and other forms that take input from you and store it. So the classic check, if you put script, alert, something, and you see a pop-up when you see the page, there is a cross-site scripting attack of stored type in this case. Then you can be more sophisticated. Yes?
Can we go back a slide?
Yes.
So what's this doing again? So is this the user detecting that there is an attacker?
Correct. So this is, the basic point is you have a website and you want to say, is this vulnerable to cross-site scripting? Well, start messing with the parameters and see if anything that you put in a query, it's printed back to you, okay? Because here you see that you pass hello world, and hello world appears in your, in your form here, in your text field. Now you can say, hey, I could give you a link that instead of having hello world has some JavaScript code. When you click on that link, this will be reflected, and the JavaScript will be interpreted in the context of this website. And so,
But the website doesn't have to be malicious, right?
no, the site as a whole, as a vulnerability, is not malicious. The malicious site is the one that contains the link with the JavaScript in it. Okay. And for example, the one of the first social network worms, I think it was on MySpace, and was Sammy, the same guy. Remember the PHP session ID? He modified the JavaScript so there was it would add, to a field, and Sammy is my hero or something like that. And since it was a stored JavaScript injection, everybody who would see that page would execute the JavaScript, go to all their friends, and leave that comment on their, let's say. And so in the matter of few minutes, he compromised 600,000 accounts, something like that. It was pretty substantial. Actually, I should put in the slide some of Sammy's worm. So we talked about stored cross-site scripting, and this is this whole problem with cross-site scripting, of course, is based on the concept that Java can be executed. And of course, you can have a simple execution that is simply used by specifying the tags. You could have something that is actually encoded, so you pass as a parameter the actually encoding of the less more, if to bypass some not so good sanitization routine. But you can also inject JavaScript in event handlers for onload, on mouse over, and so forth. And you can even have image tag source that is actually executing JavaScript. So you can have all sorts of different techniques. And it has been for a while a cat and mouse game where all these social sites are trying to fix their JavaScript execution problems. People find super contrived way to get to JavaScript execution, and and the state of the art usually is that there are a lot of restriction on what the code is in order to prevent this type of attacks. There is also the third, just 1 second, let me finish it. There's also a third type of cross-site scripting injection, which is the DOM-based. And you can see here, for example, this is the code that is sent to the user. And it's something that's simply write. Document write is a way to modify the web page using JavaScript. So the JavaScript is served to the client, and the JavaScript run here and modifies the web page of the user. And in this case, for example, puts something that is extracted from the URL, from the href, okay? And for example, they want to have a default option that is French, so they take the default option and they add an option tag with that value, okay? And here, of course, if you provide as an option JavaScript, you will write into the document the JavaScript, and writing to the document triggers the execution of JavaScript, okay? So that's another important part, that in DOM, if you write to a document JavaScript, that will cause an evaluation of the JavaScript, even if the file has been already downloaded. And there is a question, and then we're gonna take a break.
So if you were going to redesign JavaScript,
Yeah.
how would you do that?
That's a $1 million question. It's difficult to say because JavaScript has some advantages, some disadvantages. You can see where the direction is right now. For example, with content security policy, you have a way to say you can never have tags in code. You can never do this. You can only have JavaScript by including a whole file. So the whole file has to be JavaScript, and that's the only way you're going to have execution on my browser. That limits a lot of injections, because now the only thing you can inject is actually some kind of source remote file. But then in that case, you can say, I want to limit the files from which, the sites from which you can download JavaScript. And so you can restrict that. It's difficult to say, you ask somebody that is in formal verification and will tell you, hey, I want a JavaScript, the new JavaScript should be strong typed, should be compilable, should be verifiable automatically, so you can determine, at any point in the execution, what is the type of any variable, and you can determine if the interpreter can be attacked or confused. You have, boundary checking, all that stuff. Of course, we live in a market, so what we get is what was successful, which happens to be JavaScript, which is fun on one end. On the other hand, is completely, very difficult to manage and secure. And it's not that it's just difficult to secure. A lot of the things that cause problem is that people don't understand Java. And so they use it the wrong way. They shoot themselves in the foot. There is all these different possibilities. But let's take a 10 minutes break. So let's talk about solutions to cross-site scripting. As you can see, it's such a basic concept. Unsanitized data is sent back that it's actually, somewhat difficult. The basic idea is that everything that comes from the outside needs to be sanitized. This is the most important thing behind the cross-site scripting. Of course, we have seen that languages already have routines that are able to sanitize the code to, for example, strip tags and remove commands, the remove characters that can be used in command injection. It's very important to do sanitization the right way, right? So here is a number of rules. I will not go into every single one of them because it would be quite boring. But for example, never insert untrusted data except where you should. Never put comment, they receive from the user within a script tag, because of course then somebody just provides you with JavaScript and execute. Or, even inside an HTML comment, because of course, you think that you put untrusted data here, somebody can just close the comment and insert whatever they want. Also, HTML escape before inserting into the data. Attribute escape before inserting untrusted data into attribute, okay? You understand that the idea that you put attributes in quotes, single quote or double quote or even unquote, of course, can be used for cross-site scripting, because somebody, suppose that there is an attribute here, somebody can close the attribute, close the div, open a script, put some code, close the script, and do everything else. So also JavaScript escape before inserting untrusted data into HTML JavaScript data values. Okay, so when you put stuff into the quote of something, you cannot do, for example, an alert using untrusted data. Escape CSS too, because cascading style sheet also can cause problem with the property value. URL escape before you put this in URL attributes like href and similar stuff, because of course this can also escape into a JavaScript context. And sanitize HTML markup with a library designed for the job. Do not run your own sanitization system. Also, if we want to prevent DOM-based cross-site scripting, you always have to think that data can be displayed and can be interpreted as new JavaScript by when you modify a document. Also, if you want to build document interface, the right way to do it is to actually call the create element and set attribute, because this will not trigger an interpretation of the DOM. When you use actually inner HTML or document write to modify the thing, since you fundamentally say, hey, once again, here's a string, make it some HTML, then of course the parser needs to be engaged to find out what the string does. So in this case, when you modify on the client side the DOM and you use inner HTML or document write, you are triggering a new parsing of the DOM. Instead, if you do the work and you actually create the element and connect them in the tree that represents the XML or XHTML document, then that will not be triggered again because you already done the work of parsing. So there are a lot of solutions. In general, the open web, I don't remember what OWASP stands for now, but thank you. This website has a lot of resources about cross-site scripting, SQL injection, how to make, in general, this more secure. And I have to say that, you know, both cross-site scripting and SQL injection can be represented very well in automated fashion, and therefore, you will find seriously hundreds of papers on modeling, detecting, and processing cross-site scripting in all sorts of web applications. Because it is a very easy to automate process, finding these vulnerabilities, because fundamentally is a taint analysis process where you define a path between a source, that could be a parameter in a query, could be a cookie, and a sink that could be a print instruction or a SQL query in the case of SQL injection. Of course, this is great. The challenges here is that in general, scripting languages are difficult to analyze because they have crazy type or have no type system. So it's not always easy to understand exactly how data is passed. Also, there is the problem that we mentioned before of the invocation of the order of the different components, and also determining if the sanitization per se is done correctly is hard. And actually, we have a paper that we published a few years ago called Saner, in which we did a study of how web applications were sanitizing the content. And we found that many applications did it wrong, period. You know, they were sort of like creating their own sanitization routines, and they were making mistakes. And so they thought they were sanitized, but they were not. And this is an example. Can you see where the problem here is? So this is a function to use regular expression to take away things that are not A to Z, 0 to 9, dot dash, the character at, semicolon, slash, slash. These are anything that is not in these character sets will be removed, okay? Because it's a negated group of things. And so I say, oh, that's, you know, this will allow URLs to be there, HTTP, whatever, but no JavaScript. There is no way you can put, for example, less than or more than or anything like that. You see what the problem is? You do?
The dot hyphen at, maybe?
Yes, absolutely. So very good, very good. So the main idea here is that these are character classes. So there are ranges of letter. The guy said, I want to allow the dash character. So put a dash here, but this became a character class from dot to at, which allows for equal, open parenthesis, close parenthesis, so you can inject JavaScript like crazy. So it's a very subtle mistake that made that, you know, regular expression replacement completely useless. Another way to prevent cross-site scripting attack is content security policy. Yes?
Is that a general problem with regular expressions, or is it just that particular
Well, it's that regular expression because that dash should have been escaped to say, I want the character dash. But forgetting to escape the dash created instead those things like a range of characters that included bad characters.
So
If you could run that at work. Yeah, of course. That's a good question. You can sanitize right. The problem is that getting sanitization right can be actually more challenging than one thinks. Yes?
I mean, in this case, I don't think it could have been correctly written because if you have a URL that you can go JavaScript ... then you can just put your code there and it will be in the right.
True. That's a good point. In this particular case, you have the semicolon, so you could do that. But let's assume that you could not put a JavaScript semicolon thing, then it would have worked. But there are wars. If you think about there was a particular blog in which describing this social network that will go unnamed, where somebody found a JavaScript attack and they put a regular expression to catch that thing, and then find another way to go around, then they put another regular expression, and then and at the end they were able to do the original attack because by they were circular by modifying the regular expression. They open a little hole here, and so it can be frustrating. One way to limit the effect of cross-site scripting is content security policy. So fundamentally, it's a series of directives that are sent as headers in the reply that allows, certain things. For example, you can disable eval. You can say, I don't want this JavaScript ever to call eval, because in my code, I don't put eval. So if somebody trying to inject code, they cannot use eval to execute arbitrary JavaScript. And of course, nowadays I think all major browsers support the content security policy, but it's something that is extremely useful. For example, you can say default source self, to force all content to be downloaded by that website, so you don't download externally. Yes?
Is there a way to trick a modern browser into disabling the content security policy when it should be enabled?
Not that I know of, but possibly. I don't know about a specific attack. Yes?
A proxy, a CDN, an ESP could...
Oh, yeah, of course. If somebody as a proxy is able to remove your content security policy, that's an effective way to remove the security policy. Absolutely. And you can also specify a subset of other sites from which you can, for example, download things. And you can, for example, you can decide that you can download images from wherever you want, but you can only download script in addition to the self thing, also from scripts.js.com. So you can really determine or specify the scope of the execution of the JavaScript. Yes?
Can you specify that has to be downloaded over HTTPS or another secure connection?
So this is, the question is if you can specify that JavaScript is downloaded over HTTPS. Yes, you do that by putting in the URL that actually references the JavaScript. You don't need the content security policy.
Okay.
Because when you do inclusion of a JavaScript thing, you can specify the full URL and you can say, I want this to be downloaded over HTTPS.
So if I specify the URL as HTTPS and for some reason it comes back as HTTP,
it should not ever happen.
Okay.
If you specify something to be downloaded with HTTPS, it should never happen. It could happen if you specify a link in a relative form. So, source equal /jQuery.js, then depends on what's the page downloaded over HTTP, then the relative thing will also be downloaded over HTTP. But if it's downloaded over HTTPS, unless you express it differently, it will be downloaded over HTTPS. And now let's talk about the second attack, in addition to cross-site scripting, that is cross-site request forgery. In this case, fundamentally, you use the information of an open session to execute functions on a website on behalf of the attacker. So this is the basic idea. You have an existing session, so the user has logged into bank.com, and there is a cookie and everything else, right? Now, while this session is active, the user, the victim, access a malicious web page. Okay, so at this point, the malicious web page that is sent, for example, as an image tag, they say, hey, transfer this amount to this bank account that is owned by the user. Since there is this image tag, the browser of the victim will say, oh, I have to go to this bank account, to this account, and pass this as a parameter. And of course, in this case, the cookie will be sent because this is the bank.com website, and so the user happily will provide the cookie for the session, effectively doing the transactions on behalf of the bad guy. Okay, so you can see that in this case, the problem is even, if you want, more subtle. The way you get around it, well, you can avoid using get methods, but you can always inject JavaScript and create form and submit them, so it's not really a good point. You can use the referrer header to make sure that the request comes from a web page that you recognize that should have that particular thing, but if the referrer, for example, is removed by a proxy, is not very useful. So the real countermeasure here is, and you will see if you look at modern websites, they fundamentally all have in every form a secret that is added for each possible transactions that you could do. So that when you submit this form, this hidden value that is not shown to the user will be passed along. And the application can say, oh yeah, that's a form that I sent to the user. To the user, I sent this unique number included in the form, so I know that this request is because somebody clicked on that form, not because somebody, forged the form and was able to create the secret. So this prevents people from performing cross-site request forgery. Another interesting attack is clickjacking. So clickjacking is a form of GUI confusion in which you try to confuse the user into clicking into the wrong thing. And this is interesting because you can fundamentally force the user to perform actions that are not the intended action. And it will be clear in a second. The attack also is called UI redressing, but fundamentally is exploit the fact that browser can have overlapping frames that are one above the other, so different website, completely different website that can be stacked above each other. It can have different level of transparency. And so the trick that somebody came up with, say, hey, I can, for example, make a website on top completely transparent, so you don't see it, and I put a website under, and you will see through. But when you click, since the one is on top, you click actually on the real one. So this would be an example where you create 2 iframes, okay? One that has, for example, facebook.com, and a z index of 2, and then you create another one which has, for example, achieve nirvana, click on this button and you will be awesome. And you can see that the z index here is 1. Okay, so the z index here is 2, the z index here is 1. So the net result is that in front of everything, there is actually the Facebook page. Okay, this is the Z level 2, and it's completely transparent. So the user only see the button that say press here to achieve nirvana. You're gonna be super happy. So when the user actually clicks, he thinks that he's clicking on this, but he's actually clicking on the Facebook account. Okay, and by doing this, you can sort of drive the user to click on things like reset password, and then suddenly the user doesn't know that it's reset password, or set the password to a known value. It's not always super easy to carry out as an attack because of various reasons, because you have to know exactly the geometry of where everything is, but it can be really used to confuse the user and bring them to do something that they shouldn't do. So people can do two things. Can put together some frame-busting code. There will be some JavaScript that is actually in the page and make sure that the page is not included in a frame. Okay? So because the only way to do this, you have to take the page, like Facebook, and put in a frame. If you try to take Facebook and put in a frame, you will see that it will not work. Just because there is frame-busting code that makes sure that it is not possible to put it into a frame and abuse. Somebody also did a study of the various techniques that were used to do frame busting and found that a lot of them were ineffective. They could be bypassed, so it's an interesting read. I think this was a Unix paper. And nowadays, the right way to do it is to use content security policy. You actually, something that tells in the content security policy, you cannot frame this website in your browser. And this is, but of course, if you have a browser that doesn't have security policy, then you want to reverse to some frame-busting code that is able to prevent that from creating problems. And of course, we have one final category of vulnerabilities in web application, which is, I think, the absolute most interesting, which are logic flaws. And they're interesting because it is very difficult to characterize these logics. While SQL injection, cross-site scripting, cross-site request forgery, and all that stuff, it's very easy to represent with a program. So you can write actually analysis tools that take this code, find this vulnerability at scale. You can browse the whole internet or browse the entire code repository. Modeling logic flaws is super hard because, first of all, you have to automatically understand what a program does. And in that sense, in the most general case, you will always face the halting problem. Because if you can tell what a program does, you could tell that the program halts or not, and that would be a violation of the halting problem. You can't do that. So it's very difficult. And I think that one of the reasons why these bug hunting programs have become so popular because require a lot of manual analysis. So they want to pay people. They will go, you can go on the United website, try to break into the website, find a logical vulnerability. You tell United, they give you money or miles or both. Okay? And a lot of the site, Amazon, United, have this bug hunting problem. Okay, you have to play by the rules, so you cannot break in other people's accounts or do things like that. But you can explore problems, and most of the time, the things that people find are logical flaws that are very difficult to detect automatically. Because I would be really surprised if, for example, on a Wells Fargo website, you're able to find a cross-site scripting attack. People know those level of websites are developed quite well. They don't have SQL injection. They don't have cross-site scripting. But, a logical flaw where you can initiate a process and then switch to a different thing that resets the process, then you go back and you find yourself in an inconsistent state and suddenly you can download the files of somebody else. That's possible. Who was telling me about for example, there was, this morning somebody was telling me about a bug that was in Skype where you could create, when you create an account for the first time, you're not connected to anybody in the social network. And so the first time you make one friend and then you make it unfriend, you, for some reason, be put in contact with everybody. And by doing the search on the searching, you can see the personal information of fundamentally every user. It was in a water cooler discussion, but I thought it was a good example. Another interesting example of a sort of, it's almost like a a logic flaw, but in this case, it is actually pretty easy to automate the detection. And it's based on the concept of redirection. So this is a very web-specific thing. If you have redirection, your browser is automatically redirected. So as a tester, you don't realize that after you redirect something, you still can execute some code. The output of that code, unfortunately, is not visible to you because as a tester, you see immediate redirection. And so a lot of people find themselves using redirect as a go-to statement. So, oh, if there is this problem, redirect to the login page. Like, I think that Adam, who worked on this as part of his research, was like to find a website where you would ask for, you know, I don't know if it was personal, it was information about, you know, football players, and you had to pay to get access, and you try to access the information about a certain user, and you're not logged in, you're redirected to login, so you need a login. But if you stop the redirection, they will provide you the information. You just don't see it because you're immediately redirected to the login page. So the basic idea is that you ask for something, for example, you know, some user info, and this guy say, oh no, you have to first log in, but of course, you know, this guy will then log in and go forward. Unfortunately, what happened, sorry, so it was not very informative. You can see that in this, you know, there is the location moved, but then the content of that page might still have produced. The thing is that you don't observe of this second answer is the fact that your browser immediately requests the login page, and so you don't observe what happened afterwards. So, for example, if you look at this, you know, there is this redirect. This is Ruby on Rails, and you know, say if you're not an administrator, you know, redirect to /, okay, and then it terminates. And here the developer, I think this is a real piece of code. Here the developer thought that when this happens, the code stops, but actually the code is actually executed. So here the updating happens anyway, even though the user is not an administrator. And so this code is actually executed anyway. And you have two types of users. You have, you know, benign, where you execute stuff, but you don't have anything bad happening. And you have something that is actually vulnerable because might disclose information or might even execute code to unauthorized user. And this is another, you know, example in PHP. Classic thing is like, hey, if you're not the current user and you're not administration, then go to / echo something else otherwise. Okay, the observable effect of this code is that if you're an administrator, you just send to the top of the website. But if you actually look with a proxy of the data that has been exchanged, with the redirection, you will also see this data. Okay, and so you will be able to see that data. So, and you can see, so here's the header that will redirect you, and then this is the data. Yes?
You mentioned the proxy. Would Wireshark work too?
Yes, of course. Okay. Wireshark will work too. You know, I think that Wireshark is a poor version of for web analysis, but you know, the proxies. If you look at proxies like Burp, they have, you know, complete history. You can see back and forth. You know, the different. You can modify patterns. Is a lot better.
So that might be useful for the homework.
Oh, absolutely, and well, yes, absolutely. Burp is a must. So, of course, prevention of this. You know, secure design. There are some framework that do not allow execution after redirect by construction. Of course, there are also determination of the process on redirection, or you know, patched Ruby on Rails version that will not allow this attack. One final thing that is interesting in web security is attacking actually HTTP implementation. So we'll see two examples: response splitting and request smuggling. that actually exploit the fact that, once again, there is some trust, or some, I shouldn't say some trust, there is some differences or discrepancies between how you parse HTTP requests at the server side and in intermediaries like a proxy. The first one is response splitting. And the basic idea is that you can inject data in the headers of the HTTP request. So imagine that for some reason data that is provided by the user is actually used in the header of the request. So it's put in one of the fields. Then, this is an example. For example, there is something that you want to be redirect, and you can pass as the language that is to be used something that is part of the parameter of the request. Now, since this is a redirection, then this data will be used in a location header field. They will say, oh, for example, redirect to the English version of this website. Okay? Now, the problem is that you control this. So if you send this with something that looks more like this, okay, for the language, you can see that you say, oh, language is foobar, we don't care. But then you create a new line, okay, content length, blah, 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 and you start looking at this. Now, if that data is included in the header, it will sort of terminate the header and create a different request, and it will look like this. Okay, you can see that here, by lang is new line, content length 0. So this will be the first request. Then we'll create another one with the content, and since there are multiple requests in the HTTP in this one HTTP connection, any intermediary will face the mapping the wrong way. Because usually, if I'm a proxy, I see request 1, I pass request 1, I get response, I pass over the response, I will associate that request with the response that I received. But now, in this case, I get request 1, okay, the second request will be associated with this, and the following request will be associated with this. And so, in a way, you cause the wrong association of request and reply, and by doing this, you're able to poison the cache of the proxy. A second way to do this is request smuggling. And here, what's exploited is the difference in what the server and the proxy use for parsing. Okay? So you forge a request to confuse the proxy and, once again, cause a cache poisoning attack. So in this case, for example, you can see there is a request, and there are these two header. One is 0 and one is 44. Okay. Then there is a new carriage return line field and another request for something else. Then there is, as you see, some other header injected, and then another request. And by doing this, that space after that header, okay, is something that confuses the parser. And let me explain. So the proxy will parse the request, okay, and find the content length. It ignores the content 0, and so take the second one and decides that the request is actually 44 bytes. So the proxy looks at this and say, hey, I don't know why this is here. The content length is 44. I knew a carriage return line feed. I process this override this value. So for me, this is the request, 44 characters. Okay? Sorry, wrong. This is the request, up to here, 44 characters. Okay? So it treats the data in lines 8-10 as the first request body. Okay? So it said, okay, since it's 4, 8 to 10 is the first request body. Okay? Then it will parse the following line, and it will be the client's second request. So it will take the first request up to here, and that's the second request. So we'll say whatever I get first back, I'm going to associate it to that foobar. What I get back the second time, I will associate it to the page to poison.html. Now, the server will do the opposite. It will use the first content length, okay, and so we'll assume that the first request has no body, and the second request will be the line on line 8. And so the server will return nothing, and then will return, this version, the poison. So what happens is that now you will have this page that is actually associated to the other one. Yes?
So this would not be effective against HTTPS, right?
No, this will work also with HTTPS, provided that the proxy is SSL terminating proxies.
Okay.
So it depends. Okay, if you have pure SSL, then you cannot proxy it, because how can the proxy see into the encryption? But there are SSL terminating proxies. For example, you have a company, and everybody in the company has to go through the proxy because there are security policy, whatever. But then you have to go to an HTTPS site. How do you do it? So the proxy actually terminates the SSL connection. So in the browser of the people in the company, they put a special certificate in the browser.
Right.
So they connect to the proxy stops the SSL encryption, perform the processing, and then open an SSL protected connection to the site. And so can do all this stuff.
So it's basically a man-in-the-middle SSL proxy, but
Absolutely.
It's meant to be a benign one.
Correct.
It's, like a confused deputy type of thing.
In this case, you can see that it's not really... Confused deputy usually is when you are asked to perform an action that you wouldn't perform normally, and so you get confused. In this case, it's more about the fact that HTTP can be parsed in many different ways. For example, in this case, you can, I imagine that the proxy decides to read line by line and updates the various headers until find carriage return line feed. So the first time say, length is equal to 0. Then instead of throwing an error because you have 2 content length, reads another content length and override 0 with 44. And so see the carriage return line feed and decides, okay, that's the end of my header. Okay? And so I use this number to find how far in the body up to here I interpret the request. The server instead decide that, when content length is 0, that's it. That's my request. I don't have to look for anything else. I don't need an empty thing. And so then it will start, reading the next one from here. So this is the differentiation. And as I said, this created this association of the 2 pages. And I want to finish this with, again, the OWASP top 10 web vulnerabilities. Actually, the revised version after 3 years, has been just published in October. And this shows, they do a study and they look what are the more prevalent vulnerabilities on the web. You can see that number 1 is still injection. So injection means SQL injection, cross-site scripting, command injection. This is still the most prevalent vulnerability on the web. Broken authentication, we saw various examples of that. Sensitive data exposure, this is particularly important, especially since you have seen all these breaches. There was one, in Uber for only 57 million people being, whose data was exposed. This is a new one, the XML external entities. There are weird ways in which you can reference in XML through HTTP external entities, and actually that could be abused in some corner case for code injection. Of course, broken access control. security misconfiguration, cross-site scripting, insecure deserialization, using components with known vulnerability, and I don't know if insufficient logging and monitoring is a real vulnerability, but that's what they present. So to conclude, perfectly on time, we have reviewed how web applications can be compromised, what are the major classes of vulnerabilities. Remember that there are some attacks that are similar to what we saw for application, but some are very specific of web application. In particular, in fact, the modules don't have to necessarily follow the intended flow of the application. And there are a lot of things that can happen when you execute them either in the wrong order or in an unexpected order, or you invoke even components that are not supposed to be invoked in the first place, as we have seen with that PHP library before. And always remember the basic thing behind vulnerability analysis. When you look at web application, try to determine what was the developer trying to do here and trying to violate those assumptions. If he thinks that, you will visit, this place always from the same browser, well, then use a different browser. You will have a user agent that is from a real browser, but your user agent, which is a string that determines what your browser is, you can make it whatever you want using requests, using scripts, using all sorts of automation. Remember also to use tools, and I will have a very short digression. This is a fantastic, now that you fully understand the meaning of this XKCD thing. But the basic idea is that for your enjoyment of web vulnerability analysis, I suggest at least two very good tools. One, if you remember, is Burp. Okay, there is a free version, as the limitation that there's no save and restore capabilities, but it's very nice. The other one is, I don't know if this price has been, I think it's more now. The other one is Selenium. Selenium is an amazing tool that allow you to, and I don't have a slide for it, but it's an amazing tool that allow you to actually drive a real website and, a real web browser. So you can instantiate the web browser and control it using Python. That is extremely useful if you want to do pen testing, because oftentimes you go to a website, there is so much JavaScript that executes that unless you have control of a real browser, you will not be able to see certain vulnerabilities. So I strongly suggest that you become sort of familiar with that, because both Burp and Selenium are two fantastic building blocks, not only for vulnerability analysis, but also for research in general. And with that, have a great Thanksgiving, and I'll see you on Monday.